So the code starts by defining a node. Inside the node is a declaration of an integer variable. Next is creating a node named left and right. So this node will act as the left and right pointers for the child nodes. We initialize a constructor for the node. So the value will be equivalent to the given value that will be stored in the integer variable named data. So inside the constructor, we initialize key to the value of data, and we initialize left and right to a null value. Next is creating a new class. So the class is named BST class. So basically this class will going to be implementing the binary search. So inside the class, create a node. So the node is named root. This node will hold the reference to the root node of the binary tree. Next is the constructor class for the BST class. So here it is initialized, and then inside it we initialize the root node into a null value. So next is create another method. So in this method, it is used to add a new or to insert a new node in the BST. So this method will act as a caller or a caller of a function. So it will call another function, so that function is the insert recursive. So this function will insert a node into the BST using recursion. Here is the structure of the method insert recursion. So here the use of this method will basically it will recursively transverse through the binary tree and will find the appropriate position for inserting the method with the given key. So if the current node is null, then it will create a new node, and then it will be given the value of the key, then it will return its value. Next is if the value of key is less than to the root key, then it will reinitialize the root left with a new value. Else if the key is greater than root key, then it will reinitialize the root right with a new value. So basically it compares the value the key value with the current node, and then it will determine whether it will move to left or right of the tree, and it will continue inserting according to its process, and then it will return its value. So it will return the root value, or the value of root node. So we create another method. So this method is named delete key. So this method will act as a caller, or it will initiate the deletion process by calling the delete recursive method. So let's proceed to delete recursive method. So delete recursive method. So this method, well, basically it will delete a certain node. So it will recursively transverse through the BST to find the node, and then it will delete it. So here, if root is equals to null, then it will return the value, the root value. And then if key is less than the root key, then it will delete the left key. Else, if the key is greater than root key, then it will delete the right key. Else, if the root left is equals to null, then it will return the root right. Else, if the root right is equals to null, then it will return the root left. So basically it works vice versa. So it will and then it will reinitialize the root key to the minimum value using by calling the min value method, and then it will initialize the root right, or it will delete the root right, and then it will return the root. So basically this method handles different cases. So if the node to be deleted has no children, or only one child, it adjusts pointers accordingly. If the node has two children, it finds minimum value node in its right tree, copies its key to the current node, and then deletes the minimum value node. Let's create another method. So this method is called search. So as its name says, it will search for a node with a given key inside the binary tree. It is a Boolean method. So basically it initiates the search for a node with a specific key by calling the search recursive, and then it will return true if the key is found, otherwise it will return false. So search recursive method. So this method will search for a key in the basically will search the key for it in the BST. So inside this is an FL statements. So if root is equals to null, or root key is equals to key, it will return the root value. And then if the root key is greater than key, it will return the searched value, or it will return the value from the left subtree, or it will return the value from the right subtree. So basically this method, if a node is found, or if its current node is null, it returns the node where the key is found, or null if it's not found. Next is the min value method. So this method finds the minimum value node in the BST. So this method finds and returns the minimum value node in the base tree by traversing the left subtree until reaching the leftmost left node. So basically it will just transverse until it finds or like it reaches the end of the left subtree. So here inside the code, so we declare another variable named intval minval. Inside, it will we will initialize it with the root value of the root key, and then while the root left is not equal to null, then it will initialize the value of minval to the value of root left key. Then it will initialize the root node to the value of root left. After that, it will return the minimum value. Next is in order method. So basically this method will is the way of traversing through the tree. So this first one, void in order method, it will call the in order recursive method. So here in order recursive method, so basically this method will traverse the tree from the left back to the root and then proceed to the right. And then next is the first order method. So basically it is similar to in order method. The only difference is the way it traverses. So this one traverses from the left subtree or left node next to the right and then back to the root. Next one is the pre-order method. So this method, again similar to in order and post order. So this one, the only difference is the way it traverses. So it starts from the root, goes to the left, and then goes to the right. So here at the main method, we construct or we instantiate an object using the BST class. Then here we insert a new elements or key inside the BST structure we created. So first value is 45, next is 10, next is 7, next is 12, 90, and 50. So here in this example we use the in order method to traverse through the values we inserted. Then here we deleted a node using the delete key method, so that node is 12. Then we use again the in order method to traverse through the tree. Then here we delete another method, another node. This time its value is 90. Then we used again the in order method. Next, again we deleted another. So this one it is 45. And then again we use the in order method. After that, we created another boolean variable named found. So basically this will call the search function or the search method. So it will find the 50 value, and then if it finds it, then it will return true. And then here we used again the search method to find the 12 value. Then if it finds it, it will return true. If it's not, it will return false. We try to run the code. So here, as you can see, according to the values, it is correct. So that's it, and thank you.